Today we dive into the volcanic heart of Iceland, where the restless Svartsengi reservoir continues its volcanic ballet beneath the surface. As of today, the estimated magma recharge to the Svartsengi reservoir has reached the lower limit of what was lost during the diking event on May 29th and the first week of the eruption. This lower limit is around 13 million cubic meters, while the upper limit reaches up to 19 million cubic meters of magma. This significant replenishment sets the stage for potential volcanic activity. Geodetic modeling indicates a high probability of another diking event or eruption within the next 3 weeks. Assuming a similar volume of magma needs to be recharged to build up enough pressure in the system. If a higher volume change is required, similar to the 20 million cubic meters before the May 29th event, this could take 3 to 4 weeks to achieve. Recent data analysis of the temporal evolution of fissure openings for previous Sunnux eruptions indicates a systematic southwest migration. Considering this data and the considerable fault movement within Grindavik since November 2023, the likelihood of lava extrusion in Zone 4 is now considered higher for future eruptions. Therefore, the likelihood of fissure openings, lava flows, and gas pollution in Zone 4 has been raised to medium, aligning with the assessment in Zone 3. Despite this change, the overall hazard level in Zone 4 remains considerable. The hazard map has been updated and is valid until July 23rd, reflecting these changes. The hazard for lava flow invasion has been lowered in some zones, but overall, the situation remains precarious. Ground deformation data show continued uplift in the Svartsengi area, interpreted as ongoing magma inflow into the reservoir. The deformation pattern shown by Sentinel-1 satellite images covering the period from June 25th to July 7th agrees well with these measurements. Geodetic modeling indicates that the magma inflow is now higher than before the eruption on May 29th, suggesting that another diking event or eruption is likely within weeks or months. Since the end of the eruption in the Sunnux crater row on June 22nd, seismicity in the Svartsengi region has been low, with only a few small earthquakes detected daily. Ground deformation data continue to show uplift, indicating continued magma inflow into the Svartsengi reservoir. The magma inflow rate is assessed to be in line with what has been observed since mid-January, with no evidence of a declining trend. Combined analysis of erupted volumes and volume changes within the Svartsengi volcanic system indicates that overall magma availability is higher than before. As of today, the inflow rate remains steady, with recent ground deformation data showing continued uplift in the region. This suggests that the magma flow from depth continues, causing magma to accumulate beneath Svartsengi. The uplift rate is now higher than before the eruption that commenced on May 29th. During this eruption, about 19 million cubic meters of magma left the reservoir. Current modeling results indicate that this total volume loss will be recharged to the Svartsengi reservoir within the next 3 to 6 weeks. A new hazard map published by the Icelandic Meteorological Office, IMO, shows that hazards associated with lava flow and gas pollution have been lowered in many zones. The overall assessment is unchanged except in 2 zones where the level of hazards has been adjusted. The level of hazards in Zone 3 has been reduced from high, red, to considerable, orange, and in Zone 5 from considerable to moderate. Since the end of the 5th eruption in the Sunnux crater row on June 22nd, magma continues to accumulate at depth beneath the Svartsengi region. Current modeling results indicate that this total volume loss will be recharged to the Svartsengi reservoir within the next 3 to 6 weeks. The most recent ground deformation data Both GNSS and satellite INSAR images show continued uplift beneath the Svartsengi region. The rate of uplift is currently assessed to be higher than before the eruption on May 29th. Despite the ongoing volcanic activity, the situation remains dynamic. Approximately 10 days after the eruption began, ground uplift in Svartsengi resumed, indicating ongoing magma accumulation. The ground uplift has been steady since then, but the rate is slower than what was observed between the previous events. The Icelandic Meteorological Office continues to monitor the area, and measurements in the coming days and weeks will help scientists interpret any developments in geological activity. The hazard assessment has been updated in light of the developments in the eruption and weather and gas distribution forecasts. The assessment is mostly unchanged, aside from Zone 5, where the hazard due to lava flow has increased. There is still a very high hazard in Zone 3, the Sunnukur Crater Row, where the eruption started. There is also a high hazard in Zone 4, Grindavik, and Zone 6. In Zones 1, 5, and 7, there is a considerable hazard, orange. The hazard map is valid until June 20th, barring any developments. After 800 years of calm, volcanoes have awakened in the Reykjanes Peninsula of Iceland, about 56 kilometers, 35 miles, south of the nation's capital, Reykjavik. Since 2021, a string of eruptions has disrupted everyday life in the densely populated area, leading to evacuations, power cuts, and infrastructure damage. While there is no risk of a global calamity, researchers now warn that the eruptions originating from the Reykjanes Peninsula could continue for years or even decades. The prolonged volcanic activity could lead to more disruption and potentially force the long-term evacuation of Grindavik, a fishing town of over 3,000 residents that's also the gateway to Iceland's biggest tourist attraction, the Blue Lagoon geothermal pool. According to Valentin Troll, a professor at the Department of Earth Sciences at Uppsala University in Sweden and lead author of a study on the eruptions, the ongoing volcanic activity suggests that Grindavik may need to be evacuated permanently. The eruptions are likely to continue as observed over the last 3 years, supported by recent scientific evidence. Researchers have combined geochemistry and geophysics to predict future volcanic activity, revealing a primary underground source of magma fueling the eruptions in the Reykjanes Peninsula. Hugh Tuffin, a reader in volcanology at Lancaster University in the United Kingdom, praised the study for its solid case for frequent eruptions in the coming years. The research indicates that a single magma reservoir beneath the volcano Fagradalsfjall supplies eruptions at different positions on the Reykjanes Peninsula, depending on shifting stresses in the crust. Iceland, roughly the size of Kentucky with a population of nearly 400,000, boasts more than 30 active volcanoes. The high number of volcanoes is due to the island's location on a boundary between tectonic plates, creating cracks that allow magma to rise. The Reykjanes Peninsula is situated on this plate boundary, and it seems we are witnessing the early stages of a major eruption episode. There is now a vast barrier system around Grindavik to protect the town, with lava pushing against it in many places. A power plant in the area supplies Keflavik International Airport, the country's main airfield. If the power plant is affected, there could be energy shortages at the airport, impacting international travel. However, the probability of an Eyjafjallajökull-style event is slim because the situation in the Reykjanes Peninsula is different, with shallow lava fields and eruptions not reaching the levels of Eyjafjallajökull. The research team examined the issue from geochemistry and geophysics perspectives. Geochemical analysis of lava samples from various locations revealed that the eruptions are fueled by a shared magma reservoir located 9 to 12 kilometers below the surface. Geophysical analysis of earthquake patterns connected to the eruptions identified a cluster of deep seismicity at the same depth. This combined approach indicates that individual, smaller eruptions are likely to continue for some time, but simultaneous eruptions along the entire peninsula are unlikely. The combined use of geochemistry and geophysics is not frequent, but provides educated guesses on future eruptions. The study's strength lies in combining two independent methodologies to arrive at similar conclusions. Geochemistry shows the magma is from the same source, and seismic tomography reveals a single main reservoir at depth, strengthening predictions. Monitoring seismic activity is crucial for predicting volcanic eruptions. The Icelandic Meteorological Office continues to monitor the area, and data collected in the coming days and weeks will help assess the situation. While the current volcanic activity in the Svartsengi reservoir and surrounding regions is dynamic and evolving, it provides valuable insights into the complex interplay between geological processes beneath the surface. Don't forget to hit that like button, smash subscribe for more jaw-dropping space updates, and join us as we embark on a cosmic journey like never before.